Okay, so today we talked about triangle proportionality on a coordinate plane. And so what that basically means is that we're going to be doing triangle, similar triangles, but on the coordinate plane. So this was question number 12 from our workbooks on page 176. This was the question that talked about the farmer that wanted to build a barn somewhere between the house and the pasture, but that it has a ratio of 7 to 1. And so they gave us a couple of coordinate points, -22 and then 12, -6, and we're supposed to try to figure out where on that coordinate plane to put the barn, okay? So what we did was we kind of went through this smaller problem first, and then we worked out number 12. So let's look at the smaller problem first. The first thing that it says is that, we're looking for a point P that's going to divide A and B into a ratio of 1 to 2. So what I have done is I have plotted this point, -2, 7. It's actually right here labeled A. B at 10, -2 is down here. And then the part that can sometimes seem a little strange is that this ratio of 1 to 2. And so what does that look like? On the graph, it looks like having your line split into 3 separate pieces, and that one of the equal parts is the ratio from the 1, and then 2 of the parts together is the ratio to 2. And so here it is again split into 3 equal pieces, so the ratio 1 to 2 looks like that. The question is, how do we get this point right here? So how do we get numerically that answer at 2, 4? And I'll show you numerically how that works in just a second. If we go look at the next slide, what we're going to do is we're actually going to use the slope. So we're going to count the rise and run, and we're just going to divide, okay? So the rise from point A to point B is actually going to be 9. And the run from point A to point B is actually going to be 12. Since we are doing 3 equal parts, we're going to divide both of those numbers by 3. And so from point A, we're going to go down 3 over 4. That gives us the first dot. Down 3 over 4 gives us the second dot. So that's our 2 equal parts. And if I go down 3 over 4 one more time, there's my 3 equal pieces, okay? And then we can just decide, right, that it's this one. So again, I'll show you what that looks like on notebook paper in just a minute. Let's go back and look at the barn problem again. So plotting the barn problem, okay, so if we put the points in there, here's the house, which is at -20, +2. Here's the pasture at 12, -6. We're just going to count the rise and the run. This particular picture, each one of those grids actually stands for 2 places. And so this has a rise of, even though there are only 4 boxes, this actually is a rise of 8. And then the run is actually a run of 32. Okay, and since we want that ratio to be 7 to 1, we need it to be 8 equal parts. Okay. And so we would end up dividing each of those by 8. And then it will give us the point that we wanted to locate the barn. Okay? So what I have here is actually the same triangle that is representing the house, the pasture, and the barn. And I just wanted to show you that as we go through and travel according to what we are going to travel, remember when we were looking at this, right, our rise was 8. And so when we divide by 8, we get 1. This being a 32, when you divide by 8, you get a 4. And so what happens is on this particular coordinate plane, we're going to go down 1 over 4. So here's our first partition. So that's 1. Down 1 over 4, there's our second partition. Here is our third, 4th, 5th, 6th, 7th, and then the 8th one is going to get us down to where the pasture is. And so the question was the ratio being 7 to 1, And since we want there to be 7 pieces and then 1, the point that we're actually looking for is this one down here where point J is. Okay, so what we're going to do now is we're actually going to go through and do, I'm going to go through and do the first one with you, and then I'll probably go through and do number 4 with you as well so that you can see what it looks like on both paper and Geogebra. All right, so let's go ahead and actually do number 1 from the problems that are given to you. So we're going to do number 1 with you, and then I'll probably go through and do number 4 with you as well. We're going to do this on notebook paper so you can see what it looks like on what you write down. And then we're also going to do it on Geogebra so you can see what the triangle looks like and that sort of thing, okay? So here we go. Here is number 1. We have our 2 points, A, B, and then it tells us we want our ratio to be 1 to 4. So what we're going to do is we're going to start by calculating our rise and run, okay? Now, I like to label my paper so that I know what is what, but remember that the rise, these are going to be the Y values or the Y numbers. Your run is going to be your X values or the X numbers, okay? And remember, in your points, it always goes X first, then Y, okay? So what we're going to do to calculate the rise and the run, if you remember the slope formula from ever ago, right, from forever ago, it was Y2 minus Y1. Of course, you don't have to necessarily do it in that particular order, but the reason I'm showing you this is because you have to subtract, okay? So let's go subtract our Y values. So I'm going to do -7 minus 8. That's going to give me a -15. Then I'm going to subtract my X numbers, so -6 minus 4, which gives me a -10. Okay. And then what we're going to do is we have to calculate how many partitions are we going to need. So if we want a ratio of 1 to 4, that means that we need 5 equal parts, okay? So we're going to go divide these numbers by 5 because that's going to give us those 5 equal parts. And so -15 divided by 5 is -3. This one gives you a -2. And so the slope that we're going to use, the rise and the run, is going to be a -3 and a -2. Okay, this is what the slope that we're going to use to get there. Now, how do we determine, again, the coordinate point, right, that's actually on our graph? So remember, the -3 represents your Y numbers, the 2 represents your X numbers. But here's what we're going to do. So starting at point A, which is -6, -7, okay, we're going to take -6 and we're going to subtract our X value that we partitioned out, which is -2. -6 minus -2 is actually going to give me a -4. -7, the Y value, we're going to subtract the Y partition. So we're going to subtract -3. So -7 minus -3 is also going to be a -4. So it just so happens that those numbers are the same. But this, because it is a 1 to 4, notice that we did our slope thing just the one time. And that represents the 1 to 4 aspect of it, okay? And so here's where it's going to be. So let's go look at Geogebra and see what that looks like. Let's go check our answer on the graph, okay? All right, so here we are on Geogebra. I have my point A, my point B, and what I'm going to do is build that triangle. Again, we're just using this to check our answer, okay? So I'm just building the triangle, and then we're going to figure out the slope thing. So according to our slope, we were supposed to partition this into 5 equal parts, and we were supposed to go, our rise was 3 and our run was 2. So if I start down here at A and I go up 3 over 2, I'm right here, which by the way is the point -4, -4. Okay, but let's keep going. If I go up 3 over 2, up 3 over 2, and I keep doing that. Okay, I can check. I have 1, 2, 3, 4. There's my 5 equal parts. So my ratio of 1 to 4 works. And then this point down here, this negative 4, 4 is correct. Okay? All right, let's go do it again. All right, so this is one of the hairiest problems that is on there, and that is number 4. So let's go through this. We're going to do the same thing that we did before, right? We're going to find our rise and run values. We're going to calculate it, and then we're going to check our answer on Geogebra, okay? All right, here we go. So rise value, remember, are the y numbers. Run is x's. And so here we go, 13 minus negative 2. Remember, you always subtract, okay? That's going to be 15. Negative 10 minus 5 is also a negative 15. I need a ratio of 3 to 12, and so that means that we need 15 equal parts. So I'm going to divide by 15. So I'm going to get a 1 and a 1, okay? So now what I'm going to do is I'm going to start from A. Okay, so negative 10, 13, and we're going to do our rise 1 and 1. Okay, now part of the reason why we're doing this together is so that you can see obviously the difference between the positive 1 and the negative 1, but then this is the aspect that is weird, okay, the fact that it is a 3 to 12 and not like a 1 to 4 or a whatever, okay, a 1 to something. So what I'm going to do, I'm going to take my x number, so I'm going to start at negative 10, and I'm going to subtract my run number, which was negative 1. So I'm at negative 9, okay? I have 13 as my y number, and I'm going to subtract its rise number, which is 1, so I'm at 12. The problem is that this is only one partition away. This is only one step. So I'm going to need to do this twice more. Or I can instead, so I can do it again, right? So negative 9 minus negative 1 is negative 8. 12 minus 1 is 11. Do it again. And I'm at negative 7. I'm sorry. And 10, okay? Or I can take care of all three at the same time. So negative 10, 13. I'm going to change this number. I'm going to subtract my negative 1 3 times because I need that partition to be a 3. That step is 3. So I'm going to be doing negative 10 plus 3, which is negative 7. Notice I got the same answer. Okay, let's do the 13. So 13 minus my rise, which is 1, but 3 times. And so that's 13 minus 3, which is 10. And check it out, I have the same answer. Okay, so it's a little bit different because of the ratio being a 3 to 12, but we can still go check our answer on Geogebra. All right, so here it is. I've got it all set up on Geogebra ready for us. I've got my triangle ready, and again, my rise and run is 1 and 1, and so I go down 1 over 1. There it is. Each one of these is going to be a point, and as I start to count them, okay, 3 to 12, the point that I'm looking for is this point right here where G is. And if we look at where we are, so I guess it helps if I could count, right? We want 3, not 4, as I'm looking around like, what's happening? What's happening? What's going on? We want this point up here. I just can't count. It doesn't help when your math teacher can't count. So you want this point up here, and that is the point that we got. The negative 7, positive 10. Listen, even Hunsaker every now and again is crazy, right? All right, so shoot me an email if you need any help. I wish you the best. Just try. That's all I ask, okay? See you guys.